Hi, this is Chris again. I'm here to talk about Unit 64, Example 5, from Mathematics for Machine Technology by Smith and Peterson. I'm an instructor at Shoreline Community College. Example 5 is a rather complicated diagram involving three tangent circles above a straight line at the bottom, which we're asked to calculate x. And we're given the angle in the right-hand corner, 72 degrees, 40 minutes. So what information do we have and what do we need to calculate to find x? Well, we have the radii of the circles, and I've shown those in purple. Those we can use to help us calculate x. But we'll need to add the sections in yellow here, which we'll need to calculate using some triangles. So let's get started. So the first circle we have is the radius of the smaller circle. That's 500 thousandths. The other section in purple is the sum of the two other radii, 750 thousandths and 1 and 125 thousandths. So that's 1 and 875 thousandths. To complete the x, we're going to need to calculate three other triangles, triangle A, B, and C, to calculate the horizontal distances in each of those triangles. Let's get started with triangle A. Notice that the line for the hypotenuse of A goes from between the two centers of the two smaller circles, 500 thousandths and 750 thousandths. So if we add those together, we'll have the hypotenuse, which is 1 and 250 thousandths. On the left-hand side, the height of the other side of that triangle is the difference between 1 and 462 thousandths and 720 thousandths, which is 742 thousandths. Now we can calculate A using the Pythagorean theorem. C squared minus B squared equals A squared in this rearrangement of the theorem. And we can take the square roots of both sides to calculate A. So the squares of those numbers give us that. The difference of the squares is 1.011936, and its square root is 1.005950297. Rounding that to 3 decimal places, we get 1 in 600 thousandths. That's A. To calculate the rest of it, we'll actually divide the rest into two triangles. First, we'll draw a line parallel to our end line down to the base. Next, also from the center of the circle, we'll draw a vertical. We know the height of that vertical on the left-hand side. That's 1 in 462 thousandths. And using that and the angle, we'll be able to calculate B. So the tangent of that angle is equal to the opposite over the adjacent. We have the adjacent, actually we have the opposite, so we'll have to rearrange the formula to solve for the adjacent. So we'll divide the opposite, the 1 in 462 thousandths, by the tangent of 72 degrees 40 minutes. That gives us 456 thousandths and a little more. So that's the distance B. We'll round it to 456 thousandths. Finally, we're going to calculate distance C. What we're going to do is we're going to take the radius of the circle where it's tangent and forms a right angle, and we'll move that radius down until it meets the other line we dropped, the parallel line, at the base. Now we know the length of that because that's the radius. We have the angle. Now we've got the opposite, and we're looking for the hypotenuse this time, so we use the sine function. When we rearrange to solve for the hypotenuse, we divide the radius of that circle by the sine of 72 degrees 40 minutes. That gives us 1 178.5 thousandths. Rounding that, we'll get 1 and 179 thousandths. Now we have all the pieces of the puzzle to get our length. All we have to do is add them all up. So we add up the 500 thousandths, the 1 and 6 thousandths, 1 and 875 thousandths, 456 thousandths, and 1 and 179 thousandths. The total is 5 and 16 thousandths, and that's the answer to this example. I hope you found this interesting and worthwhile. Bye.